Okay, guys, so today we're going to take a look at topic 14, right, focused mostly on the reference tables, pages 2 and 3, right, New York State landscape regions and drainage patterns. So there are different types of landscapes that we find in New York State, and our landscapes are going to be the surfaces of the earth, right, that we generally break down into three different types. Okay, and if you take a look at page 2 in the reference tables, I'm going to jump to it. Right, here is page 2. When we look at it, right, there are three major types of areas. Okay, we have mountains over here, right? We have plateaus, okay? We have plains, which are lowlands. So when we break these down, right, our three major areas are going to be mountains, plateaus, and plains, which can be lowlands. All right, so plains can be lowlands. Right? Your mountains are your highlands, right? Your plateaus are also highlands. They're slightly different, right? But your plains are your lowlands, okay? And if we jump back to the reference tables, okay, we take a look. This is us down here. This right here, right about that C there, where I put the X, that on the Atlantic coastal plain is where Brentwood is, okay? And we are a lowland. So those are the three major types of landscapes found in New York State. So let's break them down. Okay, first we have mountains. If we take a look at the mountains, we could see all of these kind of pointy tops, all right, uneven, it kind of goes up and down, all right? So mountains are going to have a higher elevation. Right? We all know what a mountain is. It's an elevation, a place that has a higher elevation. Okay, there's lots of relief. What does this word relief mean? All right, relief means that there is a lot of change in altitude. And we could take a look. Not only do we have these really high ones over here, but we have all of these kind of lower bumps, right, that come in here. And this is what makes up a mountain range. It's never just one thing, right? So it kind of bumps up and down. Right? Usually characterized by deformed bedrock. Deformed meaning that it has been altered or changed in some way, folded or faulted, right? And if you think of a sheet of paper, if you took a sheet of paper and kind of squeezed it together, kind of pushes in, it's going to bump up in the middle, that's going to be folding. We've all folded paper before. This is a typical block diagram, meaning a side view where we could see the mountain bumps all in here, but you can also see right here, this area right here looks like it's folded, okay? It's been pushed in on this side and on this side, causing the paper to bump up. And what you usually get is the bumps, right? And then in between, you're going to have a valley kind of like that, and see this kind of yellowish line running down here that indicates a river. Right? Rivers are going to flow usually through the lowest part of the valley. So if I come back up to the diagram up here, anywhere where we'd have water flowing, right? If it rains, water is going to flow in this low area here, right? Down in here because of the mountains. Right, next, we have a plateau. So if we take a look at the plateau, right, and this is a picture of the Grand Canyon, notice it's still an elevated area, so it's still a high elevation. But the biggest difference is we don't have all those peaks. So there is very little relief, meaning it is fairly flat. And I know this is kind of deceiving because it kind of looks like it goes up and down like that. But you could see that, you know, you have almost steps, and you can see I highlight them here, right? Those are the flat areas. This is because we're looking at it from the side and below. But if you look at this, this is all pretty much flat across the top. Okay, so plateaus have horizontal bedrock. So if you look down here, right, unlike the mountains where you saw those kind of bumps going up and down, these, and I'm terrible at drawing straight lines, but these pretty much go straight across. Ignore that line. Right, so that is a plateau. Next, we have a plain. All right, plains, picture where we live. All right, Long Island is almost completely flat. All right, and this is a perfect example of the Atlantic coastal plain. Right, this is a beach, so plains are a low elevation. Notice you don't see any big tall mountains, you don't see any elevated areas. There's very little relief as well. All right, meaning change in elevation. It's very, very flat. Right, and pretty much our ground is going to be made up of horizontal bedrock, meaning flat layers again, only there's no areas that kind of push up. So if you take a look at this, right, if we have a plain, rivers aren't going to kind of shoot straight through. Notice they're going to kind of meander and wander back and forth, right? Picture the way you guys are in the hallway. You're not going to always go right to class. You wander back and forth. You stop at a locker. You stop at the bathroom. You say hi to a friend, right? And that's what causes you to take longer to get to places. Well, same thing with the river. Starts here, and instead of going in a straight line, it's going to wander back and forth. Very common on plains. Okay? So next, we have landscapes that are shaped or affected or created by different climates. So we talked about in the previous topic 8, the two different types of climates. So we have a humid climate here on the left, and we have an arid climate here on the right. Right? And if we remember, humid meant that it was going to be wet. So humid is a wet climate, right? Whereas arid is dry. Okay, so when we have a humid climate, right, the precipitation, meaning rain, snow, is going to feed streams, which is going to round the surface, right? If it rains up here, so let's say we have a cloud over here and it rains, right, all of that water is going to run over the surface, run off straight down, and notice that there are no bumps or steps. It's going to round off those rocks, break them up, and it's going to carry them down to the bottom. Okay, so this would be like kind of where Brentwood is on Long Island, and then as you work your way down, let's say Fifth Avenue towards the beach, you get this kind of plain area. Right, so humid, a lot of water, there's going to be a lot of plants. You're going to have that growth. Okay. On the other hand, when we have an arid climate, there is pretty much no rain, very little water. So all of this, the rocks are going to be affected by abrasion. Now, what is abrasion? If you've ever gone outside, right, and kind of run around, fallen, scraped your elbow, scraped your knee, ripped the skin off on that, that is abrasion. Okay, it's essentially rubbing. In dry climates, what you tend to have is wind. The wind is going to blow the sand around, and sand is going to rub up against these other rock faces over here and abrade or slowly break off the rock pieces, leaving very steep cliffs, right, and even jagged, meaning that, right, you're going to have this kind of like almost squared off edges, right, unlike if you look over here where it's kind of rounded and works its way down. Okay, there's very little sand, right, type of sandy soil, right, and everything is going to be very dry. Again, that's what arid means. Okay, and also should be obvious, but when you're in a dry climate, there are very few plants. You'll get cactuses, right, and lots of succulents, meaning things that can hold on to water very well. So here's an example of humid landscape. Notice everything, all these hills are nice and kind of smooth and bumpy, and also lots of green plants. Right? Whereas an arid landscape, this is in the desert of the southwestern United States. Notice, right, there are very few plants, mostly rocks, and a lot of the surfaces are just straight off, especially on those bigger features. Yes, you have kind of these like areas that look kind of rounded or smooth, but that's because all the rocks that break off of this fall down and kind of roll out to here, creating this kind of bump. Again, humid, lots of green, flowing, rounded off edges. Arid, you can see this is a perfect example of squared off. All right. Lastly, we have stream drainage. Now, when picturing stream drainage, or when thinking about stream drainage, you have to think about, well, if it rains really hard, where is that water going to go? So picture the street in front of your house. If it rains really hard, yes, everywhere is going to get wet. But where do you see your puddles? Where do you see that deeper moving water? the middle of the street tends to be higher. So you'll have kind of that bump in the middle of the street, but now right on the side over here or on the side over here, the parts that are known as gutters, all of that water is going to flow from the middle of the street down to the side, kind of like that. So when looking at stream drainage, that's what you want to try and figure out. So the shape of that landscape is going to determine which way the streams and rivers are going to flow over that surface. If you have a hill, water is going to flow down the sides of the hill. The steeper the hill, the faster the water flows. Okay, so the pattern that the water moves over the surface is known as a drainage pattern. So let's take a look at some. Okay, so in order to determine the pattern of the region, you have to kind of look and picture which way the streams are going to move. So if I took water and poured water over here, all of that water, whether it's on this side here, is going to flow down into that kind of middle area, kind of like that, leaving a drainage pattern that looks like this. I know it's a little tough to see here, but this kind of is like a rounded hill. So if you have a rounded hill, if it rains here, all of that water is going to flow off to the side. So this is the top, right? This is the top. Picture like, the top of a mountain, right? And water is going to flow off on all sides. If you have something like a plateau, something like this, where you have these kind of steps, right? You have this area here where the water can channel and build up, and then anywhere it rains on that, on the sides, is going to flow into this. And see how this is kind of tilted down? It's going to do the same thing over here, giving us that. And then, see how we have this kind of cut off here? Well, if we look at this, right, we have all of this water kind of flowing this way, right, and then it's going to hit this cutoff and flow down, which is why we get that. Right? And then finally, right, this is kind of like the rarest type where you have kind of a bump here in the middle. So this would be the top, but now there's kind of flat areas. So see how there's this, and then it looks like there's this kind of step over here, right, and step down. This is your tallest point. So water is going to flow into this step, right, and it's going to channel around to the side, and eventually it'll find the lowest point and move off. Again, picture water moving over any surface. If I poured water, let's say on a table, okay, so let's say I poured water, this is your table is flat like that, right? If I poured water in the middle of the table, the water is going to run over all different sides of the surface because the table is completely flat. Now, if I had, let's say, a table or let's say two pieces of wood that looked like this, no matter where I pour the water is all going to move down into this middle area because that's where it's going to flow. So let's apply that to the reference tables, right, on page 2 and 3 in the reference tables. So this is page 2, and notice we have the Adirondack Mountains, right, your mountains, you have your interior lowlands, these are your plains, okay, your Grenville Province, again, highland, more lowlands, right, and your plateaus. So all of these are broken down. Now let's take page 3. Notice, here are your bedrock. Now, I understand the only thing that we've used this for so far is latitude and longitude, meaning if we wanted to find out the latitude of Slide Mountain right there, we would look and we'd go over, okay, Slide Mountain has a latitude of 42 degrees, and then since it's right on that, it would be 0 minutes, and the direction would be north. Yes, that's not what we're looking for in this case. So, go away. In this case, we're going to try and match up the two. So we have this area here, which on this map is the Adirondack Mountains. Okay. Then we have this area, and notice the pattern changes, but again, this is a different region, the Tug Hill Plateau. This big area over here, right? That's going to be your Allegheny Plateau. So these two match up. So let's take a look at them side by side. Right? So now we can apply different cities and different locations in New York State and figure out what type of region they're in. So let's take a look at, let's say, Old Forge, which is right here. right? We apply that, come straight over here. Old Forge is right about here, so that makes Old Forge a town that is in the Adirondack Mountains. Brentwood is down here, which we should have marked off. Brentwood is right here on the Atlantic coastal plain. Ithaca, which was a big city that we looked at earlier. Ithaca is going to be right here on the Allegheny Plateau. So that's how these two maps work together. Okay, now it's not exactly a perfect match, but you can get a really good idea. We've all heard of, let's say, the Catskills, right? The Catskills in upstate New York are known as the Catskill Mountains. Are the Catskills really mountains? Well, when we look at this, right, the Catskills are part of the Allegheny Plateau. So are the Catskills really mountains? No, they're a plateau. All right. So that's how these two things work together, and these are your landscapes of New York State.